Chapter 5 review. Okay, so now we're going to work on slope fields, and this will give you a rough estimate of what the function of the derivative is going to look like without plus c. If you have a function here of x plus y, you can plug the points into the function and you can get the slopes at each point. For example, if we're going to do 1, negative 1, the slope would be 0, and at 2, negative 1, the slope would be 1.
Okay, welcome to Euler's method. Today we're going to learn how to approximate a value given the slope at that given point. So this is the form you use to find Euler's method, and this will give you your next y value. You use your initial y value and the slope at that point, previous point, and this is which value. This is how big of a gap you're going in terms of x. So like this is your differential function, and you have your initial point of 5, 6. And you can plug that into here to find the slope at that point. And then your next one to find is half a point larger than 5. So that'd be 5.5. And you have to estimate this value using this function. So you plug in a increase of 0.5 here would be 1/2. And this, you plug your original point in, it'll be 17, so it'll be 17. And then you plug in your original y value, which is 6. And then you simplify this, and you get the next y value is 14.5, and now you've now estimated using Euler's method. This is exponential growth and decay. This is the function that you'd use, and so this will be the original amount that you start with, original amount, and e is the variable e, which is 2.7 something. And this k is your rate at which you're growing or decaying. If it's positive, then you're going to grow, and if it's negative, you're going to decay. And the time, this is your variable, like at a given time, it will increase or decrease, depending on k again. And this will be your final amount at that given time. So here's a quick example of, you start with 100, let's say, people, and it grows 0.1 for every t, let's say, days. So at 0 days, you're going to have 100. But after 10 days, you'll have approximately 271 people, because you have now moved this decimal over, and it's e to the first, so yeah.
Alright, so the next topic in chapter 5 is separation of variables. So the problem we're going to start out with is dy over dx equals 2xy, and what you have to do is you have to multiply dx over to this side and divide by y. You have to get dx on the same side as x and dy on the same side as y, so you get without the integrals, you get dy times 1 over y, because you divided, and then you get 2x dx, and what you have to do from there is take the integral of both sides, and so you take the integral, do y substitution, and you get ln of the absolute value of y, and then for the other side you get x squared, but since it would be a plus c on both sides, they would just add to be c. So it would be plus c, and you just have it on one side. And then you have the absolute value of y. What you have to do to get rid of the ln is you have to e both sides. So you get 1, and then you have y, the absolute value of y, equals e x squared plus c. And you can separate these out because of if you had 2 powers, then they just add together when they multiply. And so you have the absolute value of y equals e to the c times e to the x squared. So since it's a different value of c, but it's still a constant, you get rid of the absolute value, and then you put plus minus e to the c times e to the x, raised to the x squared power, and you get y equals a e to the x squared, and a is just there, so you can see that it's a different constant. And then if you do a different type of problem where you're trying to find the particular solution, not the general, if it's going through point 0, 2, then all you have to do is plug in 2 for y and 0 for x, and you get 2 on that side, and then you plug in 0 and you get 1, and so a equals 2, and then you plug in a again and you get the final equation.
Alright, so now we're doing logistic equations. This is the logistic differential equation. dy dt is the rate at which population is changing at a given time. This is the solution to that, and y is the population at a given time. L is equal to the carrying capacity, and B and K are constants.